Say, for example, we want to find out what the angular speed is for, let's just say it's a wheel that's turning at 4 revolutions per minute. Okay, so just a wheel that's rotating at 4 revolutions per minute. So what you do is you start off with 4 revolutions per 1 minute. Okay, and what you want to do is you want to convert into the angular speed, so that's the angle per unit time. So what we're going to do is we're going to multiply by 2 pi radians per 1 revolution. So if you remember the unit circle, 2 pi radians is what 1 revolution is equivalent to. And so your revolutions cancel, and now you have radians per minute. If you multiply the numerators and denominators, you get 8 pi radians per minute. So that's your angle per unit time, your angular speed. Now if you want to find your linear speed, say this wheel that we're discussing, let's just say it has a 3-foot diameter. So say this is 3 feet. And if we remember that circumference equals pi times diameter, so circumference, the distance all the way around, so the circumference is going to be 3 pi feet for every 1 revolution. So if you go once around, that distance is 3 pi feet for every 1 turn, or every 1 rotation. So if we want to convert from 4 revolutions per minute to the linear speed, linear is like the length per unit time, we've got 4 revs per 1 minute, and we're going to multiply by, for every 1 revolution, you're going to be traveling 3 pi feet. So 3 pi feet. So you can see that the revolutions cancel, and you end up with feet per minute. So let's just multiply across. That's 12 pi feet per 1 minute. Okay, so that's angular speed and linear speed. So the next problem I want to show you, this one's a little bit more complicated. Some students have trouble with this, but again, just think about converting from the units that you don't want into the units that you do want. So let's take a look at that problem. So what we're going to do in this one, we're going to analyze a vehicle that's traveling at 60 miles per hour. Okay, some type of vehicle is traveling at 60 miles per hour. And let's just say that the tires on this vehicle, let's just say that they're 1.5 feet. Okay, that's the diameter, which means that the circumference is 1.5 pi feet per 1 rev. And let's say we want to convert to revolutions per minute. So we're starting with 60 miles per hour, the vehicle's traveling. We're going to convert miles into feet. So 1 mile for every 5,280 feet. So see how the miles cancel, numerator and denominator. So you end up with feet per hour. Now the feet, we know there's 1.5 pi feet per revolution. So let's convert 1.5 pi feet per 1 rev. So the feet cancel. See, numerator and denominator, they cancel. Now we have revolutions per hour. We want to convert that into revolutions per minute. Okay, so right now we've got hours. So let's see here. We've got, for every 1 hour, there are 60 minutes. So you can see the hours are canceling with the hours, denominator and numerator. And we're going to end up with the units we do want, which are revolutions per minute. See, revolutions per minute. So all you have to do is multiply across all the numerators, all the denominators, and divide. So we'll just do that real quick on the calculator so you have that. If you want to compare 60 times 5,280, okay, divided by, in parentheses, 1.5 pi times 60. So we get 1,120.5. So 1,120.5 revolutions per minute. So these are a couple examples for finding linear speed, angular speed. Just think of it as a unit conversion problem, and that'll make it simple to solve. So check out some of my other videos if you have other questions regarding problems you're having with your math. And if you need to, review this video again to understand these problems a little bit better. See you in the next video.